All right, get ready, because today we're going to take a deep dive into the world of physics education.
Sounds exciting.
Yeah, but we're not talking about boring old textbooks and lectures.
Oh, so what are we talking about then?
We're going beyond that.
Okay.
We're talking about cutting-edge open-source tools that are revolutionizing how we teach and learn physics.
You know, what I find really interesting about this deep dive is that it all started with a simple email.
Really?
Yeah. A professor who was teaching future physics and math teachers
Wow.
reached out to a physics education expert.
I see.
They were looking for the absolute best resources to share with their students.
That's great.
And lucky for us, the expert actually turned that email exchange into a blog post,
Awesome.
giving us a peek into their curated toolkit.
It's like we have a backstage pass to all these expert-recommended educational resources.
Exactly.
And the best part is they're open source.
Oh, I love open source.
Me too.
It makes everything so accessible.
I know, right? It means they're free to use.
Yeah.
They're accessible to everyone,
Yeah.
and often they're customizable.
It's like having a toolbox full of these cutting-edge educational resources,
Yes.
just readily available at your fingertips.
I love that analogy.
That's the power of open source.
Absolutely.
And you know what else is really cool about these tools?
Ugh.
A lot of them are built around this idea of letting students become scientists themselves.
Oh, I like that.
Instead of just passively absorbing information,
Right.
they get to experiment, explore, and draw their own conclusions.
So it's a shift from learning about to doing science,
Precisely.
which can be so powerful for
Yeah.
really understanding those concepts.
Absolutely.
Okay, so let's get specific here.
Yep.
One of the tools that the expert recommends is Easy Java Simulation, or EJS for short.
Ah, EJS, a classic.
I know, right?
It's a fantastic platform.
Yeah, and basically it lets you create and run your own physics simulations.
It's like having a virtual laboratory
Ooh.
where you can test out all these different scenarios and actually see how things work in action.
So give me an example.
You could simulate a pendulum swinging, a ball rolling down an incline. You could even simulate the orbits of planets.
Wow, that's incredible.
And what's really cool about EJS is that it's designed to be user-friendly.
So you don't have to be like a coding genius to use it.
No, not at all.
That's awesome.
You don't need to be a coding whiz to create these amazing simulations.
That makes it so accessible.
Exactly. And the expert even has this whole collection of pre-made simulations.
Really?
Yeah.
So we don't even have to start from scratch.
You can just download them and use them right away.
That's fantastic.
And they've even shared a link to their personal collection, too.
Wow, that's really generous of them.
It really shows the collaborative spirit of the open source community.
I agree.
People are so eager to share their work, help each other out, and build upon existing resources.
It's really heartwarming to see that.
It is. And speaking of helping each other out, remember that anecdote about the student teacher who needed a very specific type of simulation?
Oh yeah, I was wondering about that.
It just goes to show how dedicated the expert is to providing tailored resources.
That's impressive.
They didn't just point the student teacher to a general resource and say good luck.
Right.
They actually took the time to create a custom simulation
Wow.
of a vertical spring mass system.
Specifically for that student's needs.
That's amazing.
What a great story.
And get this, they even gave credit to the professor who taught them how to make it in the first place, linking back to the original inspiration for the model.
Talk about paying it forward.
I know, right? Okay, are you ready to move on to another awesome tool?
I am. What's next?
This one is all about bringing physics to life through video analysis.
Ooh, that sounds interesting.
I bet you're thinking about Tracker.
You got it.
Tracker is awesome.
It is. It's developed by Douglas Brown, and it lets you analyze the motion of objects in videos.
It's like having this high-tech lab right in your pocket.
I love that.
You can use it to analyze anything from a simple ball toss to a complex skateboarding trick.
Oh, that's so cool.
Yeah, and I can already see how this would be a game changer in the classroom.
Oh, so.
Students could film their own experiments, analyze the data, and draw conclusions based on real-world observations.
That's a great way to make physics more engaging.
Definitely. It brings a whole new level of engagement to the subject.
And is Tracker available for, most computers?
Yeah, it is. It's available for all major operating systems,
Perfect.
which makes it accessible to pretty much everyone.
That's great.
And if you need a little help getting started,
Yeah.
the expert even provides links to some helpful YouTube tutorials.
That's awesome, so you can just jump right in.
Exactly.
It's incredible how these tools are removing barriers to entry
I agree.
and making these complex concepts more accessible to everyone.
It really democratizes learning in a way that traditional methods often struggle to do.
Okay, so we've got EJS for simulations. We've got Tracker for video analysis. Both are amazing tools that can really bring physics to life.
I agree.
But let's take a step back for a second
Okay.
and talk about why these tools are so effective.
That's a great question.
What makes them stand out?
You know what's really fascinating about these tools? They go beyond just visualizing concepts.
Okay.
They encourage this deeper level of engagement and critical thinking.
I see. So students are not just passively watching or reading.
Exactly. Instead of just passively watching a demonstration or reading a textbook,
Right.
students using these tools become active participants in their learning.
That makes sense.
They get to ask questions, test hypotheses, and analyze data, just like real scientists.
They get to actually do science.
Exactly.
And speaking of real scientists,
Yeah.
the expert who wrote this blog post isn't just a passionate educator,
Right.
but they're also a researcher.
Oh, that's right.
And they've actually studied the effectiveness of these tools in the classroom.
That's fantastic.
Yeah, they've published articles in journals,
Wow.
presented at conferences,
Impressive.
and all of their work focuses on how these tools can enhance student learning.
So it's not just based on their personal opinion.
Exactly, and the findings are really impressive.
What have they found?
Studies show that students who use tools like EJS and Tracker actually develop a deeper understanding of physics concepts.
That makes sense.
They improve their problem-solving skills, and they even become more motivated to learn.
That's amazing.
So we're not just talking about cool gadgets here.
Right.
These are tools that have been proven to make a real difference in how students learn.
And we're not done yet.
What else is there?
Remember, the professor's original request was for resources in both physics and mathematics.
Oh, that's right. They wanted both.
Yeah.
So is there more to the blog post?
Yeah, the blog post actually touches on some awesome math tools, too.
Awesome.
And we're going to dive into those in part 2 of this deep dive.
I can't wait.
But for now, let's pause and reflect on what we've learned so far.
Good idea.
What stands out to you about these open source tools for physics education?
I think.
What are your initial impressions? We're going to come back to this in part 2, so be sure to give it some thought.
Sounds good.
Okay.
I'll be thinking about it.
Awesome.
Welcome back. It's been fascinating to learn about EJS and Tracker.
Yeah, they're really powerful tools.
I know, right? And I'm really curious to hear more about the research that supports their effectiveness.
Well, you're in luck.
Because
Because the expert we're focusing on today has done some really fascinating work in this area,
Okay,
studying how these tools actually impact student learning.
that's awesome.
There's one study in particular that caught my eye. It focused on using Tracker to help students understand projectile motion.
Projectile motion, like
Yeah,
throwing a ball or launching a rocket.
exactly. Things like that.
Okay.
The study looked at whether using Tracker to analyze videos of these types of motions
well.
actually helps students grasp those sometimes tricky physics concepts.
And what do they find?
Well, the results were actually pretty impressive.
I bet.
The students who used Tracker ended up with a much deeper understanding of things like velocity, acceleration, and trajectory,
Really?
compared to students who learned through those more traditional methods.
So it's like they were able to see those abstract concepts come to life.
Yeah, through the video analysis.
I see.
Almost like Tracker gave them this new lens to view the world.
A new perspective.
Yeah, one that allowed them to see those underlying physics at play.
Makes sense.
It's not just about observing the motion anymore, right?
Right.
It's about analyzing and understanding the forces and principles behind it.
And the expert has also done research on using EJS
Oh, yeah.
to model more complex systems, like a satellite orbiting Earth.
Now, that's a challenging concept to wrap your head around.
Even for, like, experienced physics students, I imagine.
Yeah, even for seasoned physics students.
Yeah. Trying to visualize all the forces and factors that keep a satellite in orbit.
It can feel pretty abstract, right?
Yeah, definitely.
But with EJS,
Yeah.
students can actually build and manipulate a model of the system.
So they can, like, tinker with it and see how things change.
Exactly.
That's a really cool way to learn.
It is. And in the study,
Mm-hmm.
students who used the EJS model
Okay.
were much better at explaining the factors that influence a satellite's orbit.
Like what?
Things like its velocity and altitude.
Interesting.
They could actually see how changing one variable
Okay.
affected the others,
I see.
which led to that much deeper level of understanding.
It's like taking a theoretical concept
Yeah,
and turning it into this hands-on experiment.
exactly. And that kind of active learning can be so powerful.
Definitely.
And the research really shows that these tools aren't just fun gadgets.
Okay.
They can significantly enhance the way students learn and engage with physics.
And this is just like a small sample of the research that's out there, right?
Yeah. Right, this is just a glimpse.
There are countless studies demonstrating the positive impact of these types of tools.
Across various STEM subjects.
It's really exciting to see how technology is being harnessed to create more effective and engaging learning experiences.
I agree. And you know what I find particularly inspiring is the dedication of educators like our featured expert today,
Yeah,
who not only embrace these tools, but also take the time to study their impact
right.
and then share their findings with the community.
It's really great.
Speaking of the community, remember the professor who initially requested these resources?
Yeah,
It's almost like we've stepped into their shoes, haven't we?
in a way, yeah.
We're exploring these tools, discussing the research, and thinking about how we can apply them to our own learning or teaching.
It's like we're all part of this larger movement
Yeah.
toward more open and accessible education.
And that brings us to a really important question.
Okay,
How can you, our listener, utilize this knowledge?
that's a great question.
Maybe you're a student who's always struggled with physics concepts.
Uh,
EJS and Tracker could be the tools that finally make those concepts click.
yeah, or maybe you're a teacher looking for new ways to engage your students
Right.
and help them develop a love for science.
And even if you're not directly involved in education,
Mm-hmm.
there's still a lot to gain from exploring these tools,
I agree.
the principles behind them.
Okay.
Accessibility, experimentation, data analysis.
Mm-hmm.
These are applicable in countless fields and aspects of life.
So we've delved into the tools themselves.
Yes,
We've explored the research that supports their effectiveness.
we have.
But now it's time to shift our focus to the practical applications.
That's a good idea. And in part 3,
Okay.
we'll wrap up our deep dive by exploring how these tools, including those math resources we touched on earlier, can be integrated into various learning environments.
Ooh, I'm excited to hear more about those.
Yeah, and we'll also consider the broader implications of open source education and the potential it holds for transforming the way we learn and teach.
Sounds good.
So stay tuned.
Welcome back. You know, it's amazing to think that we started this deep dive by unpacking a single blog post, and now we've explored a whole universe of open source tools
Yeah.
and research-backed teaching methods,
It really shows how interconnected the world of education is.
doesn't it?
One professor's request for resources led us to this treasure trove of knowledge.
Baldeck.
Speaking of treasure,
Yes?
remember those math resources we peeked at earlier?
Oh, yes. I've been thinking about those,
I know.
especially the G-Gobra simulations.
Me too. The ones that really piqued my interest were word problem, G-Gobra gradient of a line segment,
Okay.
and G-Gobra triangle.
They really left us wanting more, didn't they?
I know. The author knew exactly how to make us curious.
I think what really intrigues me about word problem
Yeah.
is how it addresses this common challenge in math education.
Making it relevant, right?
Yeah, like making those abstract concepts feel relevant to students' lives.
Absolutely. We've all been there staring at an equation,
Totally.
wondering, when am I ever going to use this in real life?
Exactly. But imagine a simulation
Okay.
that lets students grapple with real-world scenarios,
Uh-huh.
like figuring out how much paint they need to redecorate their room,
Okay.
or calculating the trajectory of a basketball shot.
That would be cool.
I know. Suddenly, math becomes less about memorizing formulas
Right.
and more about problem-solving and critical thinking.
It's about applying it to their lives.
Yes. And then there's GeoGebra gradient of a line segment, which tackles another concept that often trips students up.
Slopes.
Yes. And rates of change.
Visualizing those relationships can be a game changer.
It's like taking something abstract
Yeah.
and making it tangible.
Right. Instead of just looking at an equation on a page,
Exactly.
students can manipulate lines, see how the slope changes, and connect that visual representation back to the underlying mathematical principles.
Makes sense.
And let's not forget about GeoGebra triangle.
Oh, yeah, that one sounds fun.
Triangles are everywhere in geometry.
They are. Never thought about that.
And this simulation lets students explore their properties in such a dynamic way.
Okay, how so?
They can build triangles,
Okay.
change the lengths of the sides, measure the angles,
Uh-huh.
and see how all those changes affect the overall shape.
They're like a virtual playground for geometric exploration.
Exactly. All of these simulations embody the same philosophy we've seen with EJS and Tracker.
Empowering students.
Right, empowering students to become active learners.
And moving away from that passive absorption of information.
Toward hands-on experimentation and discovery.
It's so important. I think sometimes it's easy to get caught up in the specific features of these tools.
Yeah.
But I think what's even more important is the bigger picture.
What do you mean?
Like the spirit of collaboration and open access. That really drives the open source movement.
It's this belief that knowledge should be shared freely.
I agree.
That everyone should have the opportunity to learn and grow.
Absolutely. It's like a ripple effect.
I like that.
One person shares their work, others build upon it, and the knowledge spreads further and further,
Reaching so many people.
benefiting countless individuals along the way.
And you can really feel that sense of community in the blog post we've been exploring.
Absolutely.
The author's willingness to share their resources, answer questions, even create custom simulations for students.
Yeah.
It really speaks volumes about their dedication to education.
It's inspiring, and it leaves me feeling so optimistic about the future of learning.
I agree.
We're moving away from this model of knowledge hoarding and towards a model of knowledge sharing.
And that's got to be a good thing.
Definitely. So as we wrap up this deep dive,
Yeah.
I want to leave you with a challenge.
Okay, I like challenges.
Don't just let this information sit passively in your mind.
What should we do?
Take action.
I love it.
Visit the author's blog.
Okay.
Explore the tools we've talked about. See how they can enhance your own learning or teaching journey.
Maybe create your own simulations.
Yes. Analyze the motion of everyday objects with Tracker.
Or discover the beauty of triangles with GeoGebra.
The possibilities are endless.
You really are.
And remember, the most important takeaway from all of this
Yeah.
is to embrace the spirit of curiosity.
Oh,
Keep exploring and never stop learning.
great advice.
The world of open educational resources is vast and ever-growing.
It is, and there's always something new to discover.
That's the beauty of it.
Thanks for joining us on this deep dive.
It's been fun. See you next time.